In today's class, we're going to talk about the basic concept of physics, such as displacement, distance, velocity, acceleration, projectile motion, force, momentum, and others. The first term we're going to discuss in this class is distance and displacement. Distance talks about how far an object is traveling. You understand? Distance refers to the total length traveled by an object. That is what is meant by distance. So let's assume that we have city A, we have a city called A. Then the distance between city A and city B is 100 kilometers. And the distance between city B and another city C is also 100 kilometers. If we are told to calculate the total distance traveled, we are going to add the distance between A and B and the distance between B and C. That is what distance talk about. The distance is the total length traveled by an object. Do you understand? So the total distance here is what? 100 kilometer. Oh, this is 100 kilometer plus 100 kilometer. This is equals to what? 200 kilometer. Do you understand? So the distance tells us the total length travels by an object. Do you understand? The distance is how far the object is traveling. Now let us look at the other part of it, which is displacement. Displacement is the shortest distance traveled by an object. Are you getting it? Displacement is somehow similar to distance, but displacement talks about the shortest distance. Now let's look at this example. Let's say a boy traveled 8 meters east and then turned and traveled 5 meters west. Calculate the distance and the displacement. Don't forget that distance is the total length traveled by the object. So let us represent this on a number line. The boy starts. Okay, this is the 4 cardinal points. We have 4 cardinal points. This is north, south, west, east. From the question, the boy traveled 8 meters east. You understand? So he traveled 8 meters east. You understand? This is the starting point of the boy. So he traveled 8 meters east and then turned back and traveled 5 meters west. So from this point, he turned back and traveled 5 meters west. So this is 5 meters and this is what? 8 meters. Do you understand? Now we are told to calculate the total distance of the boy. The total distance refers to the total length traveled by an object. Are you getting it? So the total length is what? Distance. Distance is 8 meters plus 5 meters. Do you understand? So this is what? 13 meters. Now, how do we determine the displacement of this boy? The displacement cannot be 13 because the displacement tells us the shortest distance traveled by the object. The displacement is the displacement can be calculated using this formula. Displacement is equals to the final position minus the initial position. Do you understand? That is the final position of the boy minus the initial position. Now, in order to calculate the displacement is here. This distance, the distance between here and here, that is the displacement of the boy. You understand? So now, in order to calculate the displacement, that will be what? 8 meters minus 5 meters. That is what? 3 meters. Do you understand? So the displacement is calculated as F, the final position of the boy, which is here, 3 meters, minus the initial position of the boy, that is 0. So 3 minus 0 is equals to what? 3. You understand? And you can do it otherwise. Just subtract 8 from 5 meters from 8 meters. You are going to get the displacement of the boy. Do you understand? So the displacement tells us the shortest distance traveled by the object. Do you understand? So now it is important to note that displacement is different from distance. Distance is a scalar quantity, while displacement is a vector quantity. A scalar quantity is a quantity that has only magnitude but no direction. For example, if I said that a boy traveled 5 meters, that 5 meters, I don't know. You don't be on the that's from that statement, we are not given the direction to which the boy traveled. Are you getting what I'm saying? The direction in which the boy traveled is not given. So therefore, that is a scalar quantity. That is what distance. But peradventure, we are given a boy traveled 8 kilometers to the west. Now we are given the direction. Therefore, that is what? Displacement. So displacement has both magnitude and direction. The magnitude tells us the length which an object travels. I get what I'm saying. So both scalar and vector quantities has magnitude. But the difference between scalar and vector quantity is that one has direction and the other does not have direction. Scalar quantity does not have direction, while vector quantity has direction. So distance is a scalar quantity. You understand? Distance is a scalar quantity. Why displacement is a what? Vector quantity. You understand? And I've already given you example. Now I want you to try this. Is this a scalar quantity or vector quantity? Is this displacement or distance? When we say that a boy walked 70 miles, is that distance or displacement? Now, just write your answer down. The answer is that, now look at that statement. The boy walked 70 miles. This means that we didn't know the direction in which the boy was traveling. Are you getting it? We are only told that it covers a particular distance. Therefore, that is distance, because we are not given the direction. But in the case of displacement, we must be given the direction. Now I want you to try this. Determine whether this is a distance or displacement. A motorist traveled 50 kilometers to the east. Is that displacement or distance? Yeah, that is displacement, because we are given the direction to which the motorist traveled. Are you getting it? So when you are given the magnitude to which an object traveled and you are given the direction, that means that we are talking about what? Displacement. You understand? When we are given the magnitude which an object travels and the direction to which it traveled, that means we are talking about displacement. Now, when we are given only the magnitude, that means that we are talking about the distance. Do you understand? Now, when we have distance plus direction, that is displacement. Are you getting it? When we are given distance, 5 meters, maybe 8 kilometers, 5 meters to the east, not south, west, east. So 5 meters to the east. So this is what? Displacement. You understand? Now, so that is the basic idea of distance and displacement. Now, I want you to attempt this question. If a boy walk 30 meters eastward and then walk 40 meters northward, what is the displacement of the boy? And calculate the distance of the boy. We are told to calculate the distance and the displacement. Now, let us represent this in a diagram. These are our 4 cardinal points. You understand? We have north, south, west, east. You understand? Now, back to the question. The first part of the trip of the boy was that the boy walked 30 meters eastward. You understand? Let's say this is the starting point of the boy. So he walked 30 meters eastward. Let's say this is 30 meters. And then he covers another distance 40 meters northward. You understand? Another distance 40 meters northward. What is the distance and the displacement? Now, don't forget that I told you distance is the total length traveled by the object. Are you getting it? So the distance here, the distance is equals to the 40 meter plus 30 meter. You understand? The distance is 70 meter. Now, what of the displacement? The displacement is the shortest distance traveled by the object. In this case, the shortest distance traveled by the boy is the displacement of the boy. So the displacement here will be here. This will be the displacement. Displacement. You understand? So now, from your basic trigonometry, if we have a right angle, triangle, you can see that this has formed a right angle triangle. Now, if you have something like this in basic trigonometry, in order to calculate the length side, the longest side of this triangle, what are we going to use? Yeah, we are going to make use of Pythagoras theorem. The Pythagoras theorem states that the square of the longest side, which is the hypotenuse, the square of the longest side is equals to the sum of the square of the other two sides. I get what I'm saying? The square of the longest side, don't forget that the longest side is the displacement of the ball. Are you getting it? So the square of the longest side is equals to the square of the sum of the other two sides. So this is first side and this is another side. So that will be hypotenuse square is equals to what? Opposite squared plus adjacent squared. You understand? So the hypotenuse is what? This the displacement. We represent it as what? X. The hypotenuse is the displacement of the ball. So I'm going to represent it as x. So x is equals to opposite square. Opposite is what? Opposite is the angles. The side that faces the angles. That is what? 40. So I'm going to have 40 squared plus the adjacent is what? 30. So plus 30 squared. So x squared, which is the displacement, is equals to 40 squared. 40 squared is 1600 plus 30 squared is 900. You understand? So x squared is equals to 1600 plus 900. That is 2500. So in order to get the displacement, we have the square root of both sides. So I'm going to have square root of this and square root of this. This square will cancel this square. So I'm left with x. The square root of 2500 is 50. So the answer, the displacement is what? 50 meter. You understand? So the displacement tells us the shortest distance traveled by the object, and the distance tells us the total length traveled by the object. Do you understand? So the displacement is 50 meter. Do you understand? So I want you to take note of that. And don't forget that I told you that displacement is a vector quantity, and while distance is a scalar quantity. Now let us proceed to another concept known as the speed. What do we mean by speed in physics? The speed tells us how fast an object is traveling. You understand? The speed tells us how fast an object is traveling, and it is expressed mathematically as speed. Speed is equals to distance all over time. That is the mathematical expression of speed. So the speed tells us how far the distance of an object is changing with respect to time. You understand? The speed tells us how fast the distance of an object is changing with respect to time. Let's say we have a speed of 40 meters per second. Distance is measured in meter. Let's say we have this speed 40 meters per second. Distance is measured in meter. It's very, very important that you know that distance is in meter, okay, and time is in seconds. Do you understand? So that means that we have this distance and we have this speed 40 meters per second. That means that every 1 second, the distance of this object traveling at this speed is changing by 40 meters. Are you getting it? So for the first 4 seconds, the distance is what? 40 meters. The next 1 second, that is the second one, the distance is what? 80 meters. For the third, the distance is what? That is 80 plus 40, that is 120 meters. You understand? So the distance tells us how fast the distance of an object is changing with respect to time. No, the speed. Please, I want to take note. I made a mistake. The speed tells us how the distance of an object is changing with respect to time. Are you getting it? So now look at this. The first seconds, when the speed is 1 second, the distance is what? 40 meters. When it changes to 2 seconds, the distance is what? 80 meters. When it changes to the 3 seconds. That the distance of the object is what? 120 meters. So therefore, the speed tells us how fast the distance of an object is changing with respect to time. So when you are told to define speed in physics, speed refers to how fast an object is traveling. Are you getting it? Now, it is important to note that, peradventure, if you are given a question and the distance is in kilometer, you first have to convert to meter before you can proceed to calculate your speed. Do you understand? So, and if your time is also not in seconds, peradventure, if you are given a minute, the time is a minute, you have to convert to seconds before you can calculate your time, before you can calculate your speed. Do you understand? And also, I want you to know that since speed is distance over time, that means that speed is represented as v. V is equals to d, which is distance, all over t. Do you understand? This is the equation connecting speed, distance, and time. This is the equation. The equation connecting speed, distance, and time is what? Speed is equals to distance over time. And since speed is distance over time, this means that speed is a scalar quantity. Do you understand? Speed is a scalar quantity because it involves distance, and distance only has magnitude but no direction. So speed is also a scalar quantity. Now we have two scalar quantities. The first scalar quantity is what? Distance, and the second is what? Speed. Please, I want you to note that. It's very, very important. So now let us proceed. Let us have some work example on speed. Question 1. Given that the speed of an object is 50 meters per second, how long will it take to travel a distance of 100 meters? Now, let's first write out the parameters that we are given in the question. We are given that the speed of the object is 50 meters per second. So, v is equals to 50 meters per second. Do you understand? And we are now given that how long will it take to travel a distance of 100 meters? So we are given that distance is equals to what? 100 meters. Do you understand? Now, let me tell you, in order to determine the parameters that you are calculating, you first have to write out the parameter that was given. We already know the equation that is connecting speed, distance, and time. Now, from this, we are given the speed and the distance. That means that we are told to calculate the time. Are you getting it? So, in order to calculate the time, we are going to use this formula. V is equals to what? Distance over time. So the speed has been given as what? 50 meters. So this is what? 50 meters per second is equals to the distance. The distance has been given as 100 meters. So equals to 100 meters all over time. Do you understand? Because the question says how long. That is talking about time. Are you getting it? How long will it take to cover a distance of so? How long will it take to cover a distance of 100 meters? Therefore, we are looking for time. So now, in order to calculate the time, we have to just multiply both sides. Cross multiply. We are going to have t multiplied by 50 meters per second is equals to 100 meters. Divide both sides by 50. 50 meters per second. T is equals to 100 meters all over 50 meters per second. So the time is equals to, this will cancel this, and meter will cancel meter. So I'm left with what? Seconds. So t is equals to 100 divided by 50. That is what? 2. So the time is equals to what? 2 seconds. Or you can leave it like this, 2s. You understand? So the time is 2 seconds. So for the object will cover a distance of 100 meters in 2 seconds. Do you understand? The object will cover a distance of 100 meters in 2 seconds. Now, another concept of speed that I want us to talk about is the uniform speed. An object is said to undergo uniform speed when the object travels equal distance at equal time interval. For example, let's say a motor is traveling. Let me just represent this shape as the motor. Let's say the distance between this distance is 10 meters, and the seconds here is 2 seconds. Then it covers another distance, 10 meters, another 2 seconds. It covers another distance, 10 meters, in another 2 seconds. This motor is said to undergo uniform speed because the motor covers an equal distance as equal time interval. Do you understand? No matter how small the distance may be. Let us proceed to velocity. Now, in physics, what do we mean by velocity? Velocity is related to speed. The only difference between velocity and speed is that velocity is a vector quantity and it is expressed mathematically as V is equals to displacement. Displacement all over time. The only difference between velocity and speed is that velocity is a vector quantity, while speed is a scalar quantity. And don't forget that I told you scalar quantity has magnitude and what? Scalar quantity has only magnitude, while vector quantity has magnitude and direction. So therefore, displacement has magnitude and direction, and velocity is related to what? Displacement. Velocity is directly proportional to the displacement. So therefore, velocity is a vector quantity. Now, when you are given a question and the magnitude of the distance is given and the direction was given as well, that means that we are talking about velocity. Are you getting what I'm saying? So velocity is expressed mathematically as displacement all over time. Now let us have some work example on velocity. A motorist travels 40 meters east in 5 seconds. Find its velocity. Okay, let's start by stating all the parameters that was given in the question. The motorist traveled 40 meters east. You can see that means that 40 meters east. So we have the distance, which is the magnitude, and the direction, which is eastward. So therefore, this is what? Displacement. You understand? So the displacement is what? 40 meters. You understand? So in 5 seconds, the time given in that question is 5. Do you understand? 5 seconds. So we are told to calculate the velocity, and the velocity is given by this formula. V is equals to displacement all over time. You understand? You can see that this formula is also related to the speed formula that I gave you the other time. So, but the only difference is that when we are dealing with velocity, the d here is not distance, it is what? Displacement. You understand? So, and the v here is not speed, the v is what? Velocity. Do you understand? So that is it's very, very important that you note that. Okay, let's proceed to calculate this question. The velocity now becomes, displacement is 40, so displacement is 40 all over the time taken is 5 seconds, so displacement over time, that is v. V is equals to 8 meters per second because displacement is in meter. It is very, very important that you note that displacement is in meter and time is in seconds. You understand? So now let us proceed. Let us summarize what we have learned so far. There are 4 key points that I want you to know. Number 1, speed tells us how fast an object is traveling. Okay, the speed of an object tells us how fast the object is traveling, and speed is a scalar quantity. Are you getting it? Speed is a scalar quantity. That is point 2. Are you getting it? So speed can only be positive, while velocity can be negative or positive. This implies that when speed has direction, it becomes velocity. When direction is removed from velocity, it becomes what? Speed. You understand? For example, please, I want you to pay attention. For example, speed is what? Distance over time. And distance does not have what? Direction. Are you getting it? So 40 meters is what? Distance. But immediately they say that 40 meters east. That means that we have already had direction. So this becomes what? Displacement. And okay, now Let us have another work example on speed and velocity. An object traveled 10 meters east and then traveled 20 meters west. If the total time taken is 5 seconds, calculate the average speed and the average velocity of the object. Okay, let's start by listing the parameters that we are given in the question. The first part of the trip of the object was that the object traveled 10 meters east. So we have the first distance, first displacement, F-I-R-S-T, first displacement. The first displacement is that is 10 meters east. 10 meters east. Okay. Then the second displacement, that is 20 meters west. Okay. 20 meters west. The total time taken is 5 seconds. Time is what? 5 seconds. Okay, now we are told to calculate the average speed and the average velocity. Now, I want you to take notes. The average velocity of the object is what? The total displacement all over the total time taken. Are you getting what I'm saying? The total displacement all over the total time taken. Let's start with the velocity. Average velocity. Velocity. Oh, let me get another. Okay, average velocity. Average velocity. Okay, is equals to total displacement. Total displacement all over the total time taken. Okay, total time taken. Okay, now please, I want you to pay attention here. Let us represent this on the number line. Okay, let us represent this. The displacement on the number line. Now, the first part of the trip was that the object traveled 20 meters to the east. From our 4 cardinal points, we know that this is north, this is south, this is west, and this is what? East. Are you getting it? So the object traveled 10 meters east. So it traveled along this side. That is 10 meters. Okay. Now, the second part of the trip was that the object traveled 20 meters west. Are you getting it? Therefore, after reaching this point, the object traveled back 20 meters west. Okay, this is 20 meters. Are you getting it? Please, I don't want to get confused. Okay. Now, in our number line, don't forget that there is a point known as point 0. Abi, every other part of this place will be positive. Is that not it? This is what? Negative x. But along this side will be what? Negative. Are you getting it? This is positive x and this is negative x. Even just take note of the graph. When you have a graph like this, when you have a typical graph, this is positive y, this is what? Negative y. This is positive x and this is what? Negative x. Do you understand? So now, the first part of the trip was that the object traveled 10 meters towards the west, which is along the positive x-axis. Are you getting it? So this is positive. Then after that, it now take another trip towards the negative x-axis. That is 20 meters to the west. Are you getting it? So now, we want to find the displacement of this object. The displacement is simply minus 10. How do I get that? From this point, the total distance from this point to this point is what? 20. Hey, let me get another marker, please. The total distance from this point to this point is what? 20 meters. Okay? So now, if the total distance from this point to this point is 20 meters, but it traveled from this point 10 meters. So 10 meters minus 20 meters, that is what? Minus 10 meters. Do you understand? So the total displacement is what? Minus 10 meters. Because if I want to measure the displacement from this point to this point, that is what? Minus 10 meters. As it falls along the negative x-axis. Do you understand? Please, I want you to understand, okay? this falls along the negative x-axis. This is the point 0. This point is point 0. The first part of the trip is that it travels 10 meters. That is positive. But after that, it travels another 20 meters towards the west. That is, after getting to this point, every of this displacement becomes negative. Are you getting what I'm saying? That is, from this point to this point is 10. After that, after covering the distance that it travels towards the east, then it proceeds, the displacement becomes negative. That is why I have minus 10 meters here along the negative x-axis. Are you getting it? So when an object travels along the negative x-axis, that means the displacement will be what? Negative. So the total displacement d is equals to 10 meter minus 20 meter. This is equals to minus 10 meter. So the average velocity is equals to the total displacement, which is minus 10 meter all over the total time taken. The time taken is what? 5 seconds. So I'm going to have 5s. So the average velocity is minus 2 meter per second. Do you understand? So now let us proceed to calculate the average speed. Don't forget that the formula for average speed is equals to the total distance all over the total time taken. Okay, the total distance all over the total time taken. So now the average speed is total distance. The total distance is the distance that the object used to travel to and fro. You understand? That is the first strip that is covered by the object, which is 10 meter. The total distance is 10 meter plus 20 meter. Do you understand? 10 meter plus 20 meter all over the total time taken, which is what? 5 seconds. So that will be what? 30 meter all over 5 seconds. So the average speed is equals to 30 divided by 5, that is 6 meter per second. Do you understand? So because the total distance is the total length traveled by the object. Are you getting it? Now I want you to take notes. Speed can only be positive. Speed cannot be negative, okay? But velocity can be negative because speed refers to the distance traveled by the object all over time taken, and the distance is the total length traveled by the object. We are not taking into consideration either positive or negative sign. Are you getting it? But in displacement, we are talking about the shortest distance traveled by the object. Are you getting it? So the shortest distance traveled by this object is what? The distance from this place to this place. Are you getting what I'm saying? So that is why we have negative minus 10 here. Please, I want you to take note. Velocity can be positive or negative, but speed cannot be negative. Speed can only be positive. That is another thing I want you to note. Okay, so now from what we have learned so far, we knew that speed is a scalar quantity while velocity is a vector quantity, and speed can be only positive. That is, we can only have positive value for speed. We cannot have negative value, but velocity can be either positive or negative. For example, in this case, we have the velocity here is what? Negative 2 meter per second. Do you understand? Now let's talk about acceleration. Acceleration tells us how fast the velocity of an object is changing with respect to time, and it is represented mathematically as A is equals to change in velocity, that is change in velocity all over change in time. That is, A is equals to the final velocity minus the initial velocity all over t. Do you understand? So acceleration tells us how the velocity of an object is changing with respect to time. Do you understand? Now I want to ask you a question. Let's assume that we have a truck. We have a truck that is traveling like this. I'm not good at drawing, you understand? So just, we have the truck here. The truck is traveling. We have a truck, and we have another. We have a sports car. We have a sport car. We have a sport car. Okay. We have a sport car. Both are moving. Are you getting what I'm saying? Now, let me ask you. This is a truck. Truck. And this is a sport car. No, a sports car. Now, let me ask you a question. Which of these vehicles will have an acceleration? Of course, the acceleration of a sport car will be greater than that of the truck. You understand? Now, let's assume that the truck is moving with a velocity of 2 meter, 20 meter per second in 2 seconds. You understand? And the sport car, we have 40 meter per second in 1 second. Now we are told to calculate the acceleration of the truck and the acceleration of the sport car. In order to calculate the acceleration, you can make use of this formula. Acceleration says the change in velocity. The velocity of this truck before is at 0. Are you getting what I'm saying? Before it starts moving. So now it proceeds with the velocity 20 meters per second in 2 seconds. That is every 2 seconds, the velocity increases by this. Now, let us calculate the acceleration. The acceleration is initial velocity, the final velocity, that is 20 meters per second minus the initial velocity. The initial velocity of this truck is 0. You understand? So that will be 20 minus 0 all over 2. That is time. So that will be 20 all over 2, which is given as 10 meters per second squared. That is 10 meters per second squared. You understand? So now let us calculate the acceleration of the sport car. The acceleration of the sport car is given by this. That is 40, which is the final velocity, minus 0, which is the initial velocity, all over time, which is 1. That is 40 meters per second squared. You understand? So since the acceleration tells us how the velocity of an object is changing with respect to time, this implies that for every 1 second, the velocity of the truck is going to increase by 10 meters per second. Are you getting it? So, and for the sport car, the velocity will increase by 40 meters per second. Do you understand? So that is the basic idea about acceleration. So let's say the acceleration of an object is 20 meters per second. Do you understand? So we can create a table, time and velocity. Now at time 0, the velocity of the object will be 0. Let's assume that the object is traveling, is at rest before it is in motion. Let's assume that the object is at rest. You understand? So the acceleration is 20 meters per second squared. Oh, sorry. Acceleration is in meter per second squared. You understand? Now, don't forget that the acceleration tells us how fast the velocity of an object is changing with respect to time. Therefore, when the time is 1 second, the velocity will be what? 0 plus 20. Because this means that the velocity of the object is changing by 20 meters per second. Are you getting what I'm saying? Every 1 second. Do you understand? So for when the time is 1 second, the velocity is what? 20. Do you understand? When the time is 2 seconds, the velocity is what? 40. Do you understand? That is 20 plus 20. Now when the time is 3 seconds, the velocity is 60. You understand? So the acceleration tells us that it tells us how fast the velocity of an object is changing with respect to time. Now I want you to take note of something. If the acceleration of an object is positive, the velocity will be increasing. That is, if the acceleration of an object is what? Positive, the velocity will be what? Increasing. Now, if the acceleration of an object is negative, the velocity will be what? Decreasing. Do you understand what I said? If the acceleration of an object is positive, the velocity will be what? Increasing. If the acceleration of an object is negative, the velocity will be what? Decreasing. Now you can look at this. We have positive 20 meters per second square as the acceleration. Therefore, what happens to the velocity? You can see that it is actually increasing. Now, let's say we have an object. This is the object traveling towards the east direction with velocity of 20 meters per second, and the acceleration is equals to minus 2 meters per second squared. Now, the question is that, is this object speeding up or decreasing? I mean, slowing down. I get what I'm saying. Is the velocity of the object increasing or the velocity of the object decreasing? Now, I want you to write this down. If the acceleration and the velocity carries the same sign, if the acceleration and the velocity has the same sign, the object is speeding up. Are you getting what I'm saying? If the acceleration and the velocity has the same sign, the object is speeding up. And if the acceleration and the velocity of the object is different in sign, the object is slowing down. Are you getting what I'm saying? So now, if the acceleration is positive and the velocity is what? Positive, the object is what? Speeding up. If the acceleration is negative and the velocity is what? Negative, the object is speeding up. If the acceleration is negative but the velocity is what? Positive, the object is what? Slowing down. And if the acceleration is positive and the velocity is what? Positive, negative, the object is what? Slowing down. Now let us go back to the question. Don't forget that acceleration tells us how fast the velocity of an object is changing. Okay, let's have a table. Okay, let's have a table. Okay, let me just do the table here. Let us have t. We have t, and we have the velocity. You understand? Okay. So we have t. Sorry, this is t. We have t and we have the velocity. Okay. When t is 0, the velocity of the object is what? 20 meters per second, because it's already on motion. Are you getting it? So that is 20 meters per second. That is positive 20 meters per second. Now, when t is 1, don't forget that the acceleration is negative. Are you getting what I'm saying? So acceleration affects, the acceleration is negative. So the velocity will be what? 18. Positive 18. Do you understand? Now, when t is 2, at 2 seconds, the velocity will be what? Positive 16. When the velocity, when the time is at 3 seconds, the velocity will be what? Positive 14 and positive 12, positive 10, positive, this is positive 10, then this is positive 8, positive at 3, 4, 5, 6, 7, at 7 seconds, that is positive 6. Then at 8 seconds, that is positive 4. At 9 seconds, positive 2. Then at 10 seconds, that is positive 0. No, there is no positive 0, sorry. I'm carrying away, okay? There is no positive 0, that is what? 0. Now, at 11 seconds, what happens to the velocity of the object? It changed to what? Negative. Do you understand? Now, what I did here was that acceleration is negative. I get what I'm saying? Don't forget, from the definition of acceleration, I told you that acceleration tells us how fast the velocity of the object is changing. You see that the acceleration that we are given, that the acceleration of this object is what? Negative 2 meters per second squared. So for the first 0 seconds, the velocity is still there. That is 20 meters per second. Immediately we move to the next seconds. What happens? The acceleration decreases from 20 meters per second squared to what? To 18 meters per second, because we have a negative acceleration and a positive what? Velocity. Do you understand? So these laws hold. When we have a negative acceleration and a positive velocity, what happens to the velocity? Velocity will be what? Decreasing. Do you understand? Now let us proceed. Okay, let's have another table for the speed. Okay, the speed. Don't forget that I told you speed is distance over time, and speed is a scalar quantity. Speed is always what? Positive. Do you understand? Therefore, speed is the magnitude of velocity. Do you understand? Speed is the magnitude of velocity. So now, in order to get the speed for this is 20. This speed is always positive. So 18, 16, 14, 12, 12, 10, 8, 6, 4, 2, 0, 2. Speed cannot be negative. Do you understand? Okay. So for 12 seconds, at 12 seconds, the acceleration of the object, the velocity of the object decreases to what? -4, -4 meter per second. And the speed is what? 4. The speed is 4 meter per second. Now, I want you to pay attention. For the first half of the journey of this object, you can see that as the acceleration, as the time is increasing, the velocity is decreasing. Are you getting until it gets to what? 0. Because the acceleration is negative and the velocity is what? Positive. But immediately it clocks negative. What happens? The acceleration begins to, the velocity of the object begins to increase, but opposite direction. Are you get what I'm saying? So if the object is moving like this before, the object begins to move like this, but at an increasing speed. Are you get what I'm saying? Do you understand? So that is it. When the acceleration and the velocity shares a common sign, the object will be speeding up, as you can see. But when they share a different signs, the velocity will be decreasing. Do you understand? Now, let us proceed to gravitational acceleration. In physics, the gravitational acceleration is represented by a symbol that looks like G. That is, it looks like G is 9.8 meter per second squared. The value of the value of gravitational acceleration on the Earth's surface is minus 9.8 meter per second squared. You see, these values for G differs depending on the planet. Are you getting it? For example, the gravitational acceleration for planet E for Earth is what? Minus 9.8 meter per second squared. For the gravitational acceleration for Moon is minus 1.6 meter per second squared. So it differs depending on the planet. For example, Earth is what? Minus 9.8 meter per second squared. Now let us proceed. But we are going to be focusing on gravitational acceleration on the Earth's surface. Are you getting it? Now, from the previous lesson, we learned what negative acceleration does to velocity. Are you getting it? That is, negative acceleration decreases velocity. You understand? When the acceleration when the acceleration of an object is negative, the velocity of the object will reduce. Now, I want you to note that the gravitational acceleration of the Earth is in the y direction and not in the x direction. For example, if I have, don't forget that our cardinal point is this: y, positive y, this is positive y, this is negative y, and this is negative x, and this is positive x. The gravitational acceleration is in the y direction, because when we talk about gravity is the force that pulls an object, that makes an object to come down. You understand? So the gravitational acceleration is in the y direction. We don't take into consideration the horizontal direction, that is along the x-axis. We don't take into consideration. Now, let us have some work example to help us understand the relationship that exists between the gravitational acceleration and the velocity of an object. Let's say we have a boy standing on an upstairs, okay, and holding a ball. You understand? Okay, I'm not really good at drawing. And this is Earth, okay? Now, I want to ask you a question. If the boy dropped the ball, what will happen to the velocity? Will the velocity be positive or negative? Don't forget that the acceleration of an object tells us how fast the velocity of the object is changing with respect to time. So now, the ball, let us have the table T along Vy. The reason why I call this velocity Vy is because the velocity is along the vertical axis. Are you getting it? It's along the y-axis. Do you understand? So we are going to call the velocity Vy. Are you getting it? So now let us proceed. If the ball if the boy drop the ball, what will happen to the velocity? Will the velocity be positive or will it be negative? Don't forget that the ball is in the hands of that boy, so it has not been dropped. So at time t is equals to 0, the velocity will be what? 0. Are you getting it? At time t is equals to 0, the velocity is what? 0 meter per second. Now, immediately the boy drop the ball. At time t is equals to 1, what will happen to the velocity? The velocity will become minus 9.8 meter per second, because the acceleration that we have is what? Minus 9.8 meter per second squared. And the acceleration tells us how fast the velocity of an object is what? Changing. So that will be minus 9.8 meter per second. So at 2 seconds, that will be minus 19.6 meter per second. At 3 seconds, the velocity will be what? Minus 29.4 meter per second. Do you understand? So that is the relationship between gravitational acceleration and the velocity of an object. Now let us look at a similar example whereby the ball is being thrown up with a velocity of let's say 29.4 meter per second. Are you getting it? The ball is being thrown up first. Are you getting it? The ball is being thrown up with a velocity of 29.4 meter per second. Now, what will happen to the velocity at the first instance? Let us have another graph. Let us have another table here. Please, I want you to understand, okay? Velocity Vy. Don't forget, the reason why I represent this as Vy, velocity Vy, is because we are only considering the velocity along the vertical axis. You understand? This is the vertical axis along the y-axis. Do you understand? So the ball is being thrown up from this point at the velocity of what? 29.4 meter per second. So at time 0, the velocity is what? 29.4 meter per second. Now, immediately the time is 1 second. Though the velocity is 29.4 meter per second, the velocity will be decreasing because the acceleration, that is the gravitational acceleration, is what? Minus 9.8 meter per second. Are you getting it? Don't forget, the gravitational acceleration is negative, and the ball is being thrown up at the velocity of what? 29.4 meter per second. So though the velocity is what? Positive here, it will start decreasing by the time okay, let us calculate. You are going to see now. Now at 1 second, the velocity will be what? 29.4 meter per second minus 9.8 meter per second. Do you understand? Because we have a positive velocity and negative acceleration. The what? That will decrease the velocity of the object. In this case, that will decrease the velocity of the ball. You understand? That is what? 19.6 meter per second. Do you understand? So at 2 seconds, what will happen to the velocity? Velocity will reduce by what? 9.8 meter per second. So I'm going to have, at 2 seconds, the velocity becomes minus 9.8 meter per second. Then at 3 seconds, the velocity becomes 0 meter per second. Then at 4 seconds, the velocity becomes negative 9.8 meter per second. Then at 5 seconds, the velocity becomes negative 19.6 meter per second. Then at 6 seconds, the velocity becomes negative 29.4 meter per second. Now you can see, for the first half of the journey of this ball, what happened to the velocity? Velocity becomes decreasing. The velocity is decreasing. Are you getting it? Until it gets to what? 0. Now, immediately the velocity is minus 9.8, and the acceleration is also what? Minus 9.8. What happens to the velocity? The velocity begins to increase. It begins to increase. That is, the ball fell down towards the earth at an increasing velocity. Do you understand? So therefore, when the acceleration of an object is positive and the velocity is positive, the velocity what? Will be increasing. And when the acceleration of an object is negative and the velocity is negative, the velocity of the object, the speed of the object will be what? Increasing. But if they didn't share common sign, if they didn't share the same sign, that means that the velocity will be reducing. Do you understand? So for this, the velocity is reducing, and immediately the velocity changes to negative. The velocity begins to what? Increase. Are you getting it? So that is the basic concept. That's the basic relationship between gravitational acceleration and the velocity of an object. Now let's talk about projectiles motion. Projectile is basically an object that is acting under the influence of gravitational force. Do you understand? A projectile basically is an object that is moving under the influence of gravity. Do you understand? In the last two examples that we are given, that is the one I wrote here, when we have a ball, we have a boy that hold the ball and throw the ball down. You understand? This is a typical example of a projectile motion. That is, the ball acts under the influence of gravity. Do you understand? And another example that I do like this, as the ball was thrown up, it acts under the influence of gravity. It is the gravitational force that enables the ball to come down. Do you understand? So that is what projectile motion is all about. Now, both examples are one-dimensional projectile motion. Are you getting it? Because we only resolve the motion, we only resolve the velocity and the acceleration into one component. Are you getting what I'm saying? That is the x-axis. Now we are going to deal with two-dimensional projectile motion. Let's assume that we are given this is a ball. Are you getting it? This is a ball, and we have the earth. Okay, don't forget, a projectile refers to an object that is acted upon by gravity. I get what I'm saying. When the motion of an object is acted upon by gravity, we can say that we can call that motion projectile motion. But the body that undergoes projectile motion is known as what? Projectile. Now let's assume that this ball is kicked at a velocity of 5 meters per second. You understand? The ball is kicked with a velocity of 5 meters per second. Now, the ball will travel typically along this path. Okay? Now, the path which the ball travels is known as trajectory. Do you understand? Trajectory. You understand? The path which a projectile travels is known as trajectory. Now, let us determine the velocity of the ball along the horizontal axis, along the vertical axis. Don't forget, from our cardinal point, this is what? Positive y, positive x, negative x, and positive x. Do you understand? So now, the ball moves towards this point. You understand? So this is along the x-axis. Do you understand? So now, let me create another table. T, Vx, velocity of the ball along the x-axis, then velocity of the ball along the y-axis. So at time t equals to 0, the velocity of the ball along the horizontal axis is what? 5 meters per second. So this is what? Plus 5 meters per second. Do you understand? So now, what is the velocity of the ball along the horizontal axis? Can you guess? No. It is not. It cannot take any value. The velocity of the ball along the vertical axis is 0 because there is no movement. You can see the ball, at 4 seconds, the ball travels towards there. Are you guys what I'm saying? So the velocity of the ball along the vertical axis is what? 0. Do you understand? So this is what? 0 meter per second. Do you understand? But immediately the ball got to this point, it begins to what? Decrease. The height of the ball begins to decrease. Now, at 1 second, what is the velocity of the ball along the horizontal axis? Let me call this point A. Are you getting it? Let me call this maybe point B. Let me call this 1 second. Okay, at 0 seconds, 1 second. Let me call point B 1 second. Okay. So now, what is the velocity of the ball when the ball got here? What is the velocity of the ball along the horizontal axis? And what is the velocity of the ball along the vertical, along the vertical axis? What is the velocity? The velocity along the horizontal axis will still be constant. Are you getting it? The velocity of the ball along the horizontal axis will still remain plus 5 meters per second squared because the ball is not acted upon. The gravitational acceleration only affects the vertical movement of the ball. Do you understand? Gravitational acceleration only affects the vertical movement of the ball. That is, when the ball travels vertically, that is when gravitational acceleration affects it. But it is not when it travels horizontally. Do you understand? So now, the velocity of the ball along the horizontal axis will still remain plus 5 meters per second. So I'm going to have plus 5 meters per second. But the velocity of the ball along the along the vertical axis, that will be what? Negative 9.8 meters per second squared, because the ball is now moving towards the direction of negative y-axis. Do you understand? So I'm going to have minus 9.8 meters per second squared. Do you understand? So now, that is for 1 second. Let's assume that the 2 seconds is here. What will be the velocity of the ball along the horizontal and vertical axis? The velocity here will still remain plus 5 meters per second. Do you understand? But the velocity of the ball along the vertical axis will be what? Minus 19.6 meters per second squared. Oh, sorry. This is meter per second, okay? This is meter per second. Do you understand? Please, don't be confused. We are dealing with velocity here. We are not dealing with acceleration. Do you understand? So this is what? Meter per second. Do you understand? So now let us proceed. So the velocity of the ball at 3 seconds is what? With this will still remain plus 5 meters per second, and this will be what? Minus 29.4 meters per second. Do you understand? So that is the relationship between velocity and gravitational acceleration of a projectile motion. Do you understand? In summary, when we are dealing with projectile motion, the velocity Vx of the object will not change, unless if you are given a special case, maybe the object is acted upon by another horizontal force. That is when the velocity can change. But if there is nothing like such, that means the velocity remains constant. As you can see, the velocity is constant for every phase of the time. I get what I'm saying. So that is projectile motion. You understand? So it's very important that you note that. Okay. Now let us have another example. Okay, let's say we have a ball here, and the ball was kicked. And then it travels through this trajectory path. You understand? Okay. Let's say the ball was kicked with a velocity of 29.4 meters per second. Do you understand? Let's say the ball was kicked with this velocity. Now, the question now say, let's say along the x-axis, that is Vx, Vy. Along the y-axis, that is Vy. Velocity along the y-axis is this, and the velocity along the x-axis is say 5 meters per second. Do you understand? Okay. Now, what will happen to both Vy and Vx after 1 second? Please, I want you to pay attention. What will happen to both Vy and Vx after 1 second? Let us have another table. Okay, we have time, we have Vy and Vx. Let me put Vx first. Vx and Vy. Do you understand? Okay, now, what will happen to both Vy and Vx after 1 second? At 0 seconds, the velocity of Vx is what? 5 meters per second. The velocity of the ball along the along the horizontal axis is what? 5 meters per second. The velocity of the ball along the vertical axis is what? 29.4 meters per second. Now, in 1 second, what will happen to this velocity? Let's say this is 1 second, okay? The ball gets here. This is 1 second. What will happen to the velocity of the ball along the horizontal axis? Don't forget, the velocity will still remain the same along the horizontal axis, because the gravitational acceleration only affects the velocity of the ball along the vertical axis. Do you understand? So the gravitational acceleration does not affect the ball along the horizontal axis. Don't forget what I told you that the acceleration does. Acceleration tells us how the velocity of the object changes with respect to time. So the velocity of this object will only be affected by the acceleration, the gravitational acceleration, because the object is traveling along the vertical axis. And I told you that the gravity enable and gravity causes an object to fall. I get what I'm saying. So now an object that is traveling either vertically, either upward or downward, will be affected by the force of gravity. Are you getting it? So now, what will be the what will be the velocity of the object along the horizontal axis? That is what 5 meters per second. So this will be what 5 meters per second. Along the along the vertical axis now, what will be the velocity of the object? The velocity will what? Decrease by 9.8 meters per second. Do you understand? Because after 1 seconds, the velocity will decrease by 9.8 meters per second. Though the velocity is positive here, but it will be increasing at a decreasing rate. Do you understand? So for the 1 second, the velocity will change to what? 19.6 meters per second. Do you understand? Because the gravitational force of the earth, which is the gravitational acceleration, is what? Minus 9.8 meters per second square. This has acted upon the object. Do you understand? It has acted upon the ball. As the ball was shot, the velocity is here, but immediately the ball was in the air. What happens? The velocity is affected by this. Do you understand? So now this the velocity has reduced to this. So at 2 seconds, the velocity along the horizontal axis will still remain the same. That is 5 meters per second. But the velocity along the y-axis will still be reduced to what? That is 9.8 meters per second. So at 3 seconds, this will still remain the same. So at 2 seconds, the velocity here still remains 5 meters per second, and the velocity here is what? The velocity here is this is 19.6, this is 9.8. So at this place, the velocity here is not even increasing again. At this place, the velocity here is still 5 meters per second. This is what? 1 second, 2 seconds, 3 seconds. At 3 seconds here, the velocity along the horizontal axis is what? 0. That is Vx. But this still remains the same. That is what? 5 meters per second. Do you understand? So now, at this point here, the ball is not moving upward. Are you know what I'm saying? The velocity of the ball is 0. So at this point, the ball returns to what? Come down. Because this is the maximum height. Do you understand? So the velocity is what? The velocity along the vertical axis is 0 meters per second. Now, for the 4 seconds, the velocity will still remain the same along the horizontal axis. So the velocity along the vertical axis is minus 9.8 meters per second. So for the 5th, the velocity will still remain the same along the horizontal axis. The velocity here will be what? Minus 19.6 meters per second. So for the 6th seconds, 1, 2, 3, 4, 5, 6. Do you understand? So along the y-axis, along the x-axis, 5 meters per second, and minus 9.8. You understand? For this is what? Minus 19.6, and this is 5 meters. Don't forget, the velocity along the horizontal axis will always be constant. So this is what? 5 meters per second, and this is also what? 5 meters per second. But along the vertical axis, the velocity is reduced and is increasing, because this is what? Minus 29.4 meter per second. This is minus 29.4 meter per second. This is 5 meters per second. Now, I want to take note of something. When the velocity is positive and the acceleration is negative, what happens? The velocity begins to decrease. Do you understand? But immediately the velocity becomes negative and the acceleration is what? Also negative. What happens? The velocity increase. Are you getting what I'm saying? So that's it. Let us move to Newton's 3 laws of motion.